Okay, so let's do some exponential decay now. Okay, so we just got done doing exponential growth. Let's do some exponential decay. But before we do exponential decay, I need to show you one quick little helpful hint that's going to really come in handy here. So first thing you need to know is taking a fraction to a power. Basically just means you are not only raising the numerator, but you're also raising the denominator to that power as well. So that's like taking 2 to the second power and putting it over 3 to the second power, which is 4/9, which, let's stop and think about it. We shouldn't be surprised that that's 4/9, because 2/3 to the second power just means 2/3 times 2/3, right? And 2 times 2 is 4, and 3 times 3 is 9. So it's like squaring each of those. So 3 to the second power, or let's say 3/4 to the second power, is like taking 3 and squaring it, and taking 4 and squaring it, and that answer would be 9/16, okay? Now, let's throw a wrench in things. Let's take this 2/3 and make it to the negative second power, which means if you do what I just said, that's 2 to the negative second power times 3 to the negative second power. But then from my previous lesson, you remembered me saying that you can't have negative exponents, and when you do, you got to move that base in that exponent to the opposite side of the fraction. If it's in the numerator here in negative, it's going to be the positive in the denominator, and so on. So I kind of just need to flip those two. And then that's going to give me 3 to the positive second over 2 to the positive second. So flipping them made that positive. So my answer actually turns out to be 9/4 instead of 4/9. So do we have to go through this step and this step? Or can we go right from here to here? Yes, we can. If I were to recognize that this fraction is being raised to a negative exponent from the very beginning, I could fix this and turn it into a positive exponent by flipping them first here. So 2/3 to the negative second power is the same as taking 3/3 to the positive second power, which is then just 3 squared and 2 squared. Let me do that again with another one. Let's take 3/5 to the negative second power, and that's going to be the same as doing 5/3 to the positive second power. This answer is 25/9. Got it? So a general rule of thumb to follow is if you have AB to the negative C power, it's the same as doing B over A to the positive C power. Okay? You are going to need that when we work on our exponential decay. So let's get right to it. So before we start our exponential decay, I want to just remind you what an exponential function is. We talked about what defines an exponential function is that instead of like in a linear function, a constant rate of change means I keep adding 3, okay? Exponential function means that I have a multiplier of 3 instead of it being added, right? We talked about the difference between exponential growth and decay. We talked about the fact that growth means that you have a number, a base rather, that is greater than 1. B is greater than 1, like 2 or 4 or even 100. And then we talked about decay is not necessarily less than 1, because there are all kinds of numbers that are less than 1, like -8, but I don't want to deal with that. I need it to be between 0 and 1, meaning my base for my exponent of x has to be between 0 and 1. It can't be 0, it can't be 1, but it's all those numbers in between, which we call proper fractions, right? So when I have a base of 1/3 or 2/5 or 1/4 to the x power, we're going to get a graph that looks like this every single time, okay? So let's talk about exponential growth or exponential decay right now, okay? So I'm going to start a clean sheet because we're going to need it. So let's take a look at y equals 1/2 to the x power, all right? And if you remember what I said it's easiest to start with just 5 points. My goal is to get this on a graph. That's what I'm going to be asking you to do when you're doing your independent practices. And right now, the only way you know how to do that is to create a table of values using these 5 numbers as your domain. You can really use anything you want, but this gives you a good sampling of everything to cover that graph good. Remember what I said. Let's always start with this 0 here. Let's work these 3 and then go back and do the hard ones later. So I'm literally taking this and making it my exponent. And if you remember what I said about taking anything to the 0 power, the whole thing just becomes 1, right? And that's 0, 1 with an exponential function like this, meaning just a 1 there or basically nothing there. That's kind of your home base. That's where you're going to start. Now let's make our exponent 1. And this is where that little trick that I just showed you is going to come in handy. Well, not necessarily here, because anything to the first power is just that number, right? 1/2. Okay? So now let's do 2 to the, or 1/2 to the second power. Y is equal to 1/2 to the second power. That's where this comes in. It's not negative, so we don't have to worry about flipping it. I just need to know to do the 1 to the second power and the 2 to the second power. This is a step you don't always have to show, but I'm just showing you for a minute. Be careful, please. 1 to the second power, the biggest, most common mistake is people make that 2. It's 1 times 1, which is 1. 1 to any power is 1, right? And 2 squared is 4. So when I made my exponent 2, the corresponding y value that shot out was 1/4, okay? Now I have to do these 2 right here. Let's take that y to the 1/2 power and make it to the negative first power. So at this point, you can do that awesome flip-flop that I showed you, remember? If I don't want to take a fraction to a negative power, flip that fraction upside down and make it to that positive power. And 2/1 is really just 2. And 2 to the first power is just 2, so I'm going to put a 2 there. Now, let's take that exponent of -2, which is our x, which I want to put here, and raise that 1/2 to the -2 power. Flip it again, and take that and make it 2/1 to the +2 power, which is just 2 squared, which is 4. So if you stop for a minute and think about all those awesome tips that I showed you. If you remember back to one of our previous videos, I told you that you had 2, sometimes 3 options to figure out this part. Remember, these 3 came kind of easily. It was this part that was a little tricky. Well, remember option 3 was called the shortcut, and it only works when there is no a in front, meaning y equals 2 times 3 to the x. Nope, not going to work because that 2 throws everything off. But if I'm just doing 3 to the x or 1/2 to the x and that's just a 1, yep, that shortcut's going to work. And you remember what that shortcut was? That as soon as you kind of use this as your line of symmetry, these points will be reciprocals of each other. So this was 4, well, this was 1/4. If this is 16, then this is 1/16. Except it looks a little backwards. Here I have my whole numbers down here and my fractions up here. Well, we're doing decay. So these are the 1/2s and 4ths. And so this kind of is a reciprocal of that, and this is a reciprocal of that. Again, that only worked because that was a 1. The most important thing is I don't really care how it worked because we got the 5 points we need, and now we just need to graph them. So 0, 1 is right here, and I have that in pink, I have this in pink, and now this is in pink to show you the connection. That number is the y-intercept every time. Now look, I have 1, 1/2, and 2, 1/4. And then -1, 2, and -2, 4. All right? So it's not as big of an increase as we've seen in previous ones, but it's still an increase. I mean, not an increase, it's a decrease, but this is still increasing going up. So there is my exponential decay graph of y equals 1/2 to the x power. And I know that it's going to be a decay because going back to my original explanation of growth versus decay, when b is greater than 1, there's growth. When b is between 0 and 1, like a fraction, there's decay. So should you be surprised that your graph turned out to go this way? No, because that was 1/2. Okay? So now let's take a look at something else and see what happens when we decide to do 3 times 1/2 to the x power. So instead of a 1, it's a 3, which we know what that means. No more shortcut for this reciprocal business. Okay? Let's take our points, and now I want you to, just like you got this graph on here, I want to know your 5 points, and I want that graph on here. Table of values is your best bet. Let's use these 5 points always. Let's do some substitution. This time I want to take 3 and multiply it by whatever 1/2 to the x power is. Well, what is 1/2 to the, I'm going to start here. I mean, you've seen me do so many of these. I'm starting at 0. Let's make that 0 power. Well, 0 power is just 1. And what's 3 times 1? 3. Okay? That's going to be my y-intercept. Let's just put it there now. It's when that's 0. Okay? So now let's make the exponent 1. So y is going to equal 3 times whatever 1/2 to the first power is. Well, 1/2 to the first power is just 1/2. And 3 times 1/2 is 3/2. All right? Don't overthink it here. 3 over 1 times 1 over 2 is 3 over 2. All right? You could make it 1.5 if you want. You could make it 1.5 if you want. Whatever version you choose to put here, just make sure that it's all the same. What I would suggest is putting it as a mixed number, because this is something we're going to have to graph later. So would you rather graph 3/2 or would you rather graph 1.5? I mean, either one of these would work. Graphing 1.5 isn't so bad either. So now let's do this to the second power. Let's take that 3 and multiply it by whatever 1/2 to the second power is. And 1/2 to the second power, and you may need to kind of come to the side and do that. That's 3 times 1 to the second power is 1, and 2 to the second power is 4. I'll know what this y value is as soon as I do 3 times 1/4. Again, don't overthink it. It's 3 over 1 times 1 over 4. That's 3 over 4, right? Okay? So remember how I told you that that's there? So this kind of, reciprocal business, that's not going to work. Okay? So we know it's not going to be that. So I have no choice. I have to do another option. So, and I also did want to tell you this, that if you're doing this, you're multiplying by 1/2. So remember up here, I'm multiplying by 1/2, which is, by the way, you can tell I'm multiplying by 1/2 because it says it right here, right? Multiplying by 1/2. So here I'm multiplying by 1/2. So you could choose this option, and you could say, well, if I multiply by 1/2 from here to here, I'm going to divide by 1/2. All right? So that's one way. You could say I'm just going to take 3 and divide by 1/2, which means don't really do 3 divided by 1/2. Do 3 times its reciprocal. Hey, that wasn't so bad. That's going to be 6. Now that I know that, because it's times 1/2, go backwards and divide by this 1/2, and you'll get the previous one. So take 6 and divide it by 1/2, which is really 6 times its reciprocal. That's going to be 12. If that part to you is confusing, then watch the negative exponent way. If you want to just do it the same way every time, then go for it. Take that -1, plug it in, and that's going to give you 3 times 1/2 to the -1 power. But you got to remember that little trick. You got to remember when that power is negative, you really have to flip this and make it 2 over 1 to the +2 power, which is just 3 times 2, which is 6. Yeah, I know. We already did it, right? Let me just show it to you now with the 2 being negative. Y equals 3 times 1/2 to the -2 power, which is 3 times 2 over 1 to the positive 2 power, which is 3 times 2 squared is 2 squared is 4, and 1 squared is 1, that's 4, and 3 times 4 is 12, which we got that way. So now, like, the hardest part of these exponential functions is getting those 5 points. That is the hardest part. All of this work has to do with that. So now, once I have my points in my graph, I'm home free. I just have to plot them. So there's my 0, 3, which was right here, which is shown here, which is shown here. Here's where you see it. You see it here. You see it 0, 3 here. You see it 0, 3 here. Now I'm going to plot 1, comma, 3 halves. Oh, I mean 1 1/2. So 1, comma, 1 1/2. 2, comma, 3/4. Well, that's a half. 3/4 is right here. Okay. And then now let's plot our -1, positive 6. 1, 2, 3. If that's 3, that's 6. And then I have to plot my -2, positive 12, which is probably somewhere up here. I have my 1, 2, 3, 4, 5 points. I should not be surprised that it is going down and that it's a decay, because I knew it was going to be a decay because the base was a fraction between 0 and 1. And that is how you do your exponential decay.